today we're talking about finding asymptotes. And finding asymptotes in what we've been doing so far, problems like what was on the warm-up, that's not super complicated. I've kind of been talking about that all along. But rational functions can be more complex than what we had on the warm-up. And yeah, I'm going to give it to you this way. So we're going to say that if you're trying to find, the hard one to find is the horizontal asymptote. So we're going to focus on that first. So horizontal asymptotes. All right. Now, if we have some function, I'll call it f of x, and let's say f of x is equal to something that's way more complicated than what we've seen so far as rational functions go. Let's say it's got some number a times x to the nth plus, and then we've got all this other junk on top. I'll explain exactly what I mean by that in just a second. Just bear with me for a moment. And then in the denominator, we've got some other number b times x to the m. So these are two different powers, or they could be the same power. Plus, and then there's all this other junk here. If you're looking to find a horizontal asymptote, this is if there's no plus or minus at the end. If you're looking to find a horizontal asymptote, there's three possibilities here. The first possibility is if n is greater than m. So if the power in the numerator is greater than the power in the denominator, then there is no horizontal asymptote. No horizontal asymptote. What gets created is something called an oblique asymptote, and that's beyond what we're covering right now. And I'll show you what that looks like in just a second. So if the power in the numerator is larger than the power in the denominator, the largest of those powers, then there's no horizontal asymptote. If they're equal, then the asymptote is at y is equal to, thank you, a over b. And I'll show you an example like that too. So there's really only the three situations. You can probably guess what the next situation is. You've got n greater than m, so if the number on top, the power on top is greater than the power on bottom, no horizontal asymptote. Create something called an oblique asymptote. We don't need to cover that right now though. N is less than m? Yeah. The third situation is if n is less than m. In that situation, your horizontal asymptote is at y is equal to 0. And there's a lot of math behind this, but for right now, I'm fine with just showing you the rules and then how to apply them. So if we're looking at a situation, pretty much all the rational functions we've looked at till now have followed that form that your last homework had, that a over x minus b plus c. We're going to start looking at some that don't follow that form and how we can work with those. So I'm going to start out relatively simple here. I'm going to say I've got some function, we'll call it f of x equal to, and this is going to be equal to, let's say, x plus 4 over x minus 1. And you need to find the horizontal and vertical asymptotes to this. Now the vertical asymptote is the easiest part to find. The vertical asymptote is whatever makes the denominator be equal to 0. So 1, yeah. So the vertical asymptote, is going to be at x equal to 1. And that means that your domain is going to be x such that x cannot be equal to 1. These two things are linked to each other. The asymptote occurs at where the exception to the domain is thrown.
Wouldn't that be a horizontal?
No, that's vertical. X equals 1 goes up. Just because the x-axis goes horizontal, the formula for the x-axis is y equals 0. The x-axis is a y line, believe it or not, and the y-axis is an x line. Just when you thought you understood graphing. All right. So, next, if you're trying to find the horizontal asymptotes. Horizontal. Now you're going to use these rules I just showed you up here. So you've got, this is x with no power, which means it's x to the first. This has no power, which means it's x to the first as well. So is the numerator greater than the denominator for the powers? Are they equal?
Yeah. Equal.
Okay. So then you're going to take whatever the coefficients are.
So that'd be 1.
Yeah, and so the horizontal asymptote is going to occur at y equal to 1. Which means the range is y such that y does not equal 1. Now, how that's going to look on your calculator, because you could use your calculator to find some of this information if you wanted to. Finding the horizontal asymptote is a little trickier, but it's still something you can do by using your calculator if you're being cautious. So let's say that we have, turn the light on so you guys can see it better. Flares up for a second, then it dies down. All right, cool. So I'm going to take out my calculator. When I'm entering this in, I have to remember to put the numerator in parentheses and the denominator in parentheses. So I'm going to do parentheses x plus 4, close those parentheses, divided by x minus 1. Close those parentheses. Now, I haven't used my calculator in a little while, so rather than just hitting graph right away, I'm going to hit zoom and then go to 6 to bring up the standard window from -10 to 10 in both axes. Now, you can kind of tell from here that I'm going to have asymptotes that aren't on the axes because this crosses the y-axis. Oh, sorry. I meant to move it so that you can see the domain range, but okay, never mind. You can kind of tell right now that the asymptotes aren't going to be at the axes because it crosses the x-axis here and it crosses the y-axis there, so that's not the asymptotes anymore. However, the real meat of the information, if you want to try and figure all this out through graphing, is to go look at the table. And then you know that you're going to have an x asymptote, a vertical asymptote at x equal to 1 because that's where you get an error. And then if you want to find out where the horizontal asymptote is, you want to look at what the value approaches as you get further and further out on x. So you get closer and closer to, in this case, just about 1, but you can't always exactly tell. It's probably better just to do it algebraically, but didn't somebody get to the thousands one day when I was showing you guys this? Yeah. Okay. If that happens, so let's just say that you get you're just, I don't know, entranced by how close to 1 it's getting, and you keep going further and further out like this, and then you come back to it later and you're like, but I want to look at 0. So if you want to change your table set, if you hit second window to bring up table set, you can have your table set start back at 0 and then go back to your table and you're back at 0. You what? Okay. So second table set, change your table start back to 0 and then bring back your table and it'll be at 0.
So you could just start your table at 0?
Yeah, if you wanted to. You could do second table set 1, 1, 2, 3. Oop. And it's 1.005, and it's not going to get any closer.
What if I got over?
I don't know what you mean.
Isn't that
Okay,
over
because this is positive 1,000 is approaching 1 from the top, so it's always going to be above 1,000. It's like with that fare to the trip or whatever, it's always going to be more than 5. If I'm looking at negative 1,000, it's going to be below 1. So if I do negative, let's even do, I don't know, 1, 2, 3, 4, 5.
Will never equal.
Right.
There's no possible recovery.
So if I do negative 10,000, it's going to be less than 1. If I do positive 10,000, or actually I think I did 100,000. Yeah. If I do positive 100,000, it's going to be still greater than 1.
0.9.
Right. And then if you want to, table set back to 0, table, you're back to 0. All right.
So
if
does it
that
never just go flat?
No. Nope. It never turns into a true horizontal line. It will always approach, but never touch, and it will never turn into a purely horizontal line. It will always have at least a little bit of a decrease to it, because it can decrease infinitely without ever reaching that line. Okay. Yeah. So let's take a look at the next possibility here. Let's take a look at if we have. Bless you. Let's go, say we've got f of x equal to 3x cubed plus 5x squared minus 2x. Don't worry, it's more afraid of you than you are of it. Minus 1 all over. And let's say this is all over. I will. X squared plus 5x plus 4. Alright, so I promise you, This is not that big of a deal.
It looks like a pretty big.
It's not a big deal. It is a small deal. So the first thing you want to do is you want to try and find out what the vertical asymptote is. And to do that, you want to focus on the denominator. So you've got x squared plus 5x plus 4. You want to factor that out first, right? So two numbers that multiply to be 4 that add to be 5. 4 and 1. So this is going to factor into x plus 4 in one set of parentheses, x plus 1 in the other set. Now this one is going to, just like your warm-up, it's going to have two exceptions to the domain, which means it's going to have two vertical asymptotes this time. So those vertical asymptotes are going to occur with whatever x value is going to cause there to be a divide by 0. So which x value is going to cause this one to turn into 0?
-4.
Okay, so your first asymptote is at x equal to -4. Your second asymptote is what's going to cause this to be equal to 0. So x equal to -1, bless you. Now it doesn't matter, like, if -1 turns this one into 0 but it doesn't turn that one into 0, it doesn't matter because you're still multiplying something by 0 and it still turns into 0, right? Do you guys see that? So if these are our two asymptotes, then the domain is x such that x cannot equal to -4 and x does not equal -1.
So what does that look like when it has two asymptotes?
I'll show you in just a second. Let's get the horizontal ones done, and I'll show you exactly what it looks like.
Cross out the equal sign on -4.
Oh yeah, thank you. Come here. Thank you. Okay, now to find the horizontal asymptote, you don't need to mess around with almost any of this. All you need to look at is the power that's on top greater than the power that's on bottom?
Yes.
Okay, so that means there's no horizontal asymptote. So horizontal, no asymptote. What that also means is that your range, since there's no asymptote, is now just y such that y is a real number. So now there's no exception to the range because there's no asymptote. Now, as far as what that looks like, okay, going to, can you see that if I put it right there?
Yeah.
All right, cool. I'm going to be really cautious about my parentheses. I'm going to do 3x to the third plus 5x squared, 5x squared minus 2x minus 1, close parentheses, divided by open parentheses, x squared plus 5x plus 4, close parentheses. I just used my window, and it was just at the regular setting, so I'm not going to need to hit zoom 6. So I'm just going to hit graph. Give it a second. Okay, so you can't tell super well, but there's going to be an asymptote right here at -1. So like this is actually going to have a third part to it as well. Let me change my window a bit here. I'm going to go to, let's say, 30. I'll count by 3s. Let's try graphing it now. I shouldn't need to go too much further to the right to see the other asymptote being used, but oh no, okay. Aha, that's what's happening. So there's supposed to be a second asymptote here at x equal to 4, but what's actually happening?
-4.
Oh, sorry, -4. Aha. Interesting. Okay. Let me show you guys. Okay, have I shown you guys Desmos before?
Yeah.
The TI-84 is an awesome device. However, it's not always super user friendly, and it's what you can use on your ACT, which is why a lot of focus is put onto it. Desmos you can't use on your ACT, but it works a lot better for stuff like this. So I'm going to try re-entering that function here just so you can see it better. But yeah.
So you can put nearly anything in the it'll graph it.
Well, you can. It's not that it'll graph it. Yeah, I mean, of course it'll graph it. It's that it will. It will. Yeah, it can do that. Absolutely. It can solve problems for you, but that's not what I'm really focused on. What I'm focused on is. Let me write this down. So 3x cubed plus 5x squared minus 2x. Minus 2x.
No.
Nope. Whoa. That was weird. Plus 5x squared? Is that what I did? And then minus 1? And then I did divided by, and then it was x squared.
5x.
Thank you. Plus 5x. Plus 1. Alright, cool. So, just going to change this. Yeah, it's the same thing, but the reason why I like Desmos like that is because if I want to zoom out, I don't have to muck around with the window. There we go. It's down here. So,
I see you there.
this is approaching -4, but it's never actually going to cross -4. Zoom in just a little bit more. And then this is approaching -1, but it's never going to touch -1. Same thing with this one. So these two on the left are both approaching -4. These two on the kind of sort of right are both approaching -1, but are never going to touch it.
Wow.
And then, I mean, if I had queued you into Desmos, like it automatically finds maxima and minima. So I mean, like that whole thing you were doing before, where I had you find the maxima and minima algebraically. A little mean of me not to show you this tool as well, but it's a thing. Okay. So there's one more one more example I want to show you here really quickly, and then I will cut you guys loose. The big thing about this last problem is it looks like it's scary with all that junk in the numerator, but you don't have to do anything with it. Like I'm not asking you to solve it. I'm not asking you to factor it. I'm only asking you to see that there's not going to be a horizontal asymptote based on the power of the numerator and the power of the denominator. Does that make sense?
Okay.
Like you don't have to do anything to that top. You will have to factor the denominators, and the denominators on today's assignment and on your test are all easy to factor. So you will have to do that.
Are they all going to be difference of squares?
Not different. No. Some of them are difference of squares. Some of them are things like here. I'll give you another example of something you might see on today's assignment. Okay. So I did one where the same. I did one where the top was bigger. Now I'll do one where the bottom is bigger. So let's say that we've got x plus 1 or some function f of x is equal to, let's do x plus 1 over 2x squared.
You've had them the same.
I've had them the same. I've had the numerator larger, and now I'm going to have the denominator larger. Right? Okay, so... Okay. For this one, finding the vertical asymptotes again is the easiest part. So you're going to look to see if you can factor your denominator. What can go into both of those? 2x. So factor out a 2x, and what gets left behind? X plus 3. So the two places that are going to cause this to be equal to 0, the two values of x that will cause the denominator to be 0 are 0 and -3. Right? -3 will cause this to be 0, and then that'll be 0. And 0 will cause this to be 0, and then that'll be 0. So the two exceptions here are x equal to, the two asymptotes are x equal to -3 and x equal to 0, which means that our domain has two exceptions. The two exceptions in the domain, x such that x cannot be equal to -3 and x cannot be equal to 0.
And is that how we're going to format our answer? We're going to have the asymptote that we're going to put in the domain?
Mm-hmm. Yeah, because the assignment asks for both. It asks for the vertical asymptotes, and then it asks for the domain.
Okay.
So two separate answers. Yeah. Yeah, and on this one, the horizontal asymptote, so when you're looking at this, horizontal, and I forgot to put my L on horizontal up there. That's weird. Since the denominator has the higher power, the horizontal asymptote is just y equals 0. That's it. And then your range would be...
Why is that?
Because in the things I showed you up here, if the denominator has the bigger power...
Well, I know that, but why?
Oh, okay. Algebraically, if I were to divide this by that...
Can you just not see that that's
Zero
the rule and
divided-
just go with it?
0 divided by
Hold on,
0.
Kim, I will explain it to you individually later, so that you don't have pitchforks and angry villagers coming after you. I appreciate that you want to know why the rule exists, and I will explain it to you in mere moments. Okay. All right. So your assignment for today is asking for you to find the
like the pitch for it.
Vertical asymptotes, x-intercepts, horizontal asymptotes, and domain. It doesn't ask for range. There's no
Why do we
why.
have to do this?
Why?
Why? You gotta accept the fact that there's a why you gotta do it.
Because I'm
why.
That's why.
Because snow is bad. Snow is the essence of life.
Because the only time I feel anything is like coldest month is when I make other people feel.
All cold and snow.
Like, I like snow, it's just really cold.
Alright.
I know,
I'd
like,
rather frostbite than sunburn.
I actually don't mind summer. I'm a summer baby though, I was born in the summer.
Can we not graph?
Oh,
No.
that's a terrifying noise right there.
Oh, okay. And one thing too that I left out. If you want to graph by hand, I'll just go through one of these with you guys.
Do we have to graph? Do we have to
Yeah,
graph by-
it's part of it. Well, I mean, you can always make a choice, but you're being graded on graphing, yeah. Oh, yeah.
We have to graph by hand.
So, well, here, let me just show you. Like, you don't have to do the whole thing by hand. It doesn't have to be super exact. So let me show you one of the, I don't know, one of the harder ones on here. Let's see. 3 isn't super easy. What else isn't super easy? 10? No, 10's fine. 10 just has a horizontal asymptote of -1. Like, okay, so let's look at 10. Why not? All right. So first thing you want to find is what are going to be the vertical asymptotes. So vertical asymptotes. And to find the vertical asymptotes, you're going to focus on the denominator and factor that.
3 and 4.
Great. X plus 3, x plus 4, x plus 3, x plus 4.
X minus 3.
So x equal to -3 is one asymptote, and x equal to -4 is another asymptote. So what that means when you're going down here is you're going to draw a vertical line, and I'm going to draw mine in with dashes just to show where the asymptote is. Bear with me. This is gonna be way easier than you think it's going to be. So I'm drawing in my vertical line at x equal to -4. I'm going to draw another vertical line at x equal to -3. So those are my two vertical asymptotes. And then I need to find out what my horizontal asymptotes are. Now for my horizontal asymptotes, the powers of the two are equal. So that means I'm going to take the coefficient of this one and divide it by the coefficient of that one. So it's -1 divided by 1, which is just -1. So that means, I'll get to the domain here in just a second. That means I'm going to draw a horizontal line at y equal to -1, which is right here. Just kind of going across, filling in my horizontal line. Okay. Now, to help me out, I'm going to use my calculator. I'm going to type all of this junk in. So I'm going to do -x squared. Oh, I do, thank you. So -x squared in parentheses, minus 4x minus 3, close parentheses, divided by, open parentheses, x squared plus 7x plus 12, close parentheses. I think I had my window at a weird thing last time, so I'm going to hit zoom 6 before I graph it to bring it back to something normal. So, to graph this, what's happening is this is going like that. And notice how I'm not being super accurate with my terms. I'm just putting the graph where it should go. And then what's happening with this second asymptote here? 1, 2, 3, 4. Yep. What's happening with the asymptote at -3 is it approaches that value, but it doesn't actually have a value at -3. If you were to look at your table, -3 has an error and -4 has an error. Yeah. And then it just goes like that. And I'm not being super accurate here, I'm just making sure not to cross the asymptotes. Ta-da! Done. Oh yeah, and I gotta do domain. The assignment doesn't ask for range, so I'll just do domain. Domain is x such that x does not equal -3. and x does not equal -4. It also asks for x-intercepts, but you don't have to do that part.
I think that's what mine is. This has an error 0.
What is your top little arrow with your drawing there? Did it go in between the two?
Yeah, but there's like a... It doesn't actually have a value at -3. It kind of jumps over it.
So how do you show that?
How do you show that? I didn't do it very clearly here, so I'll do it. Try and do it more clearly. What? Is that better? Okay, I'm just going to draw an open circle right there, just to show that it skips over that second asymptote. Would you like me to do another one with you guys? Of course you would. Why not? Free answers. Who doesn't like free answers? Okay, so 10. Let's see. What else is difficult? 3. Yeah, we can do 3. That's fine. 3 and 2, I think, are the next most difficult. 2, just because the horizontal asymptote is a fraction. But like, 5 is exactly what you've been doing. 7 is similar to what you've been doing. Yeah, let's do 3. Just because 3 is one that doesn't have a horizontal asymptote. So if we're looking at this, first thing you want to do is find your vertical asymptotes. And to find that, you're going to look at your denominator, factor it out, and see what you get. So -3x squared and -6x, what can go into both of those? -3x. And when you take a -3x out, you get x plus 2. Good. Alright, so then our two vertical asymptotes are going to be at x equal to, great, and x equal to -2, which means that those are also your two exceptions for your domain. So I'm going to draw a vertical line here at x equal to 0, just kind of right over my axis, because the y-axis is actually an x line. Freaky stuff. And then I'm going to draw another one at x equal to -2. The x-axis is a y line, and the y-axis is an x line. True stories. Alright, and then with this one, because the power of the numerator is bigger than the power of the denominator, there is no horizontal asymptote. So horizontal, none. Instead, it's going to go at like this weird oblique angle. And there is such a thing as an oblique asymptote, but I'm not going to have you guys find that. That's kind of beyond the scope of this class. That's more of a calculus thing. Yeah, okay. So I'm going to do x cubed plus 5x squared plus 4x, all in parentheses, divided by, in parentheses, -3x squared minus 6x, close parentheses. I just used my window, so it should be set to a pretty standard setting. Hit graph. Oops. I have a syntax error. Where's my syntax error? Oh, there it is. That's weird. Okay. So I did 3x squared minus 6x. Weird. Okay.
Because you went over the other one.
Okay. I'm just gonna erase the whole thing then. Sorry. You guys are probably ahead of me now, which is fine. So x to the third plus 5x squared plus 4x divided by -3x squared minus 6x, close parentheses, graph. Alright, there we go. So we get this meow. Meow.
So this doesn't have to be exact at all?
It doesn't have to be exact. I'm not going to be checking to make sure that your thingy things are perfect. So I'm just going to kind of draw it in. Meow. Meow. And then over here, it's going to go this way. And it's going to skip right over that second asymptote. So I'm going to put an open circle to show it needs to skip over that, because that's a... Yep. I think I've done all the ones that are going to have an open circle anyway. So the rest of them should be pretty straightforward. Some of them are going to be super straightforward, like 5 and 6. Those are very similar to what you were graphing yesterday. Right? And then there's some review questions at the end. There's solving those rational equations that you can use either graphing or eliminating denominators because it doesn't say which one to use. And then there's some complex fractions you need to evaluate. All right? Yeah, Dylan. Yeah, I will. It's supposed to be a high of 41 today. Tomorrow it's supposed to stop snowing sometime early in the morning. And then it's supposed to be in the 30s or 40s for the rest of the week.
Good.
So it's
time to go to shield.
So they'll like one and then we don't have to do no questions. But if she does ask for the answer, you don't have to.
And it's just not over $200 from
So which is how much we're doing?
Before I say anything, we don't get the discount. Well, we can get the discount, but not for the sale price. Almost likely the 50% discount.
So if she gets it at cost, because markup at a retail.
Aye.
Because my sister's got a $200 coat for $87.
That's more than.
Well, that's more than 50%.
Sure.
Yeah, they're not gonna give it to you on the app.
Do you not have a blue item?
Those things go around.
Okay. So this one.
I think that's one that I already did. Yeah.
I can kind of smell it, yeah. I'll turn on my picture in a second. Yeah, it's 8.
No, we did this one in class.
We did most of it in class, yeah. I think, like, we didn't do these parts in class, or maybe we did, we just went through really quickly.
See if I have that.
Okay, and I can check, like, I brought my stuff back today, I just haven't gone through it yet. So if you come later today, I'll be able to give you a better idea.
Alright, this is the only one that I haven't got.
Okay.
This is the only assignment last week?
That you're going to miss for Thursday and Friday, yes.
Here, go with that.
Oh wait, no, sorry, I don't know why I just gave you that. I meant to
No,
give
you didn't give me this. I didn't have this. I
Oh,
saw you come.
that and the other one that we were doing in class.
Okay.
So this one would just
Yes. So, here, the reason why it works the way that it does is because if you have something like, yes. The fraction bar means what? So if I divide this by that, what do I have to multiply x by? So like you're gonna end up with like x plus something. I know that's not like x plus 5. This is the equation of the line. It is equal. So that's what the horizontal aspect is. Now if they're equal, then you have like x squared x squared plus 4 divided by x squared minus 4. You would do x squared plus 4 divided by x squared minus 4. What would you have to multiply this by to make it like that? Just 1, right? So this is going to have the equation of y equal to 1. which is the same as this number divided by that number. Now, if you have 6 divided by
So did I.
you're going to do x plus 1
Did I actually
divided by
I didn't even put my grammar book in my back.
I didn't even bring my gun.
there's nothing you can multiply this by. So that's why I just gave that y equals 0. Okay.
My grammar book's in the house.
No villagers, pretty easy explanation.
Well, I know Ralph Waldo Emerson. Which story of his are they doing?
Oh, this.
Yeah. Yeah, wait till Billy gets back there, yeah. He went like a couple minutes ago, it'll be fine.
I'll just read it tonight, you know. And I read it last night. Last night I was a bit busy typing up my lab report that was due yesterday. Mr. Better wasn't here, so I read it 3 times.
What? She's coming out. She said she can pick her own name. She didn't say she made a free time.
I do a lot better than you. No, school card. I don't know. Most of the people in the school actually more than most of the people here. Yeah.
Yep.
So on number 5, the top doesn't have a x.
Right, so it's just it's y equals 0 for your horizontal asymptote.
So if there's no x value, just assume the one.
It's y equals 0 unless you've got a plus at the end. Right, because now it's just like what we were doing before. Are you guys filming the wall coming down? Yeah, it's Sadie, come see me later today for the assignment for tomorrow.
I was thinking about
I actually don't know her last name. I think maybe she's from the West, which is where she's not going to come to this year because she doesn't want to marry the partner that she's doing home solo. I think she's first or second Saturday.
When you said that she was doing hum solo, I thought you said she was doing Han solo. I had a very different idea of what was going on there.
well,
or K-H-L-A-E? K-R-U-S.
Use your tab. Use number 6 tab 3 values for X.
Yeah. 0, 3, and 1.
Are you flipping here?
No, you're good.
It just seemed like a lot.
It is, but yeah. I have faith in you.
How is it spelled?
I'm not even sure the person really exists.
Oh, she does. She exists.
She's probably the Bailey.
Dawson.
Okay, so when you're like identifying someone who's like from your here, when you tell them
Yeah, well, she's from her partner from last year. John, what was his name?
I know her. There's Ollie. Autumn Alfredo.
Neither myself nor Sam remembers her partner's name. We both remember her name too.
All right, have a good day, guys.
Was she the hot one?
Well, yeah, her partner was a guy.
Oh, yeah.
So yeah, but yeah, like dang, like we had her in a round. I'm like, yep, I'm not forgetting that.
I was assumed that she was the hot one, but no judgments.
Yeah, no, like straight up, like me and Sam were like. I like the fact that she walked up to me yesterday and she's like, wow, somebody actually remembered my name. She's like, so you're not doing a duo with Sam Smith this year? I'm like, nah.
Sam's got his own shenanigans.
Yeah. So I'm stuck with Anderson.
Oh, that's awful.
Oh, yeah.
I'm sorry.
He skipped half a page of lines each time he performed.
I'm so sorry.
I was about ready to choke out the part. Thank you for bringing me back.
Too much shit.
during
That's what I think. That's the best one.
Right?
Yeah, you better keep my ear. We're starting to rut. I don't like them in breath, though. That's why I try to keep my It stinks so bad when you're in the mouth, though. Yeah. Oh, I don't. I know what it's doing.
Chris, during strike, you might went outside, just lay on the ground. There's no body currently growing.
You got pictures in your ear?
I really Huh? I really
Why?
What?
Was it a bucket list?
Why can't we not just have it all? So how do you write it down?
Kids are weird.
Several sheets of paper. I use them because we still have
I figured, I said, I told Adam that I stole one of his magic cards, but I didn't.
that you what?
That I stole one of his magic cards, but I didn't. Actually didn't, but he doesn't
Alright,
believe
come on in
me.
guys, 6 seats.
Do you have 0.5 left?
Same.
Can I chew, please?
Sure. Alright, take a seat please guys. Today we're going to go over the warm-up in just a minute. Then we're going to do quite a bit of corrections today. So we got that to look forward to.
Are we going to have an assignment today?
We are. After that we're going to take some notes. And most likely have an assignment. For the warm-up, the first one, I guarantee you've heard of that Saints. Whether you're Catholic or not, you live in America. Especially Montana, you've heard of that Saint. Yeah. Second one is the easiest kind of problem you're going to have this entire unit. So it should be easy for you to do. And then the third one, you're going to use that formula I gave you not too long ago. Okay? If you feel like you've got it done, raise your hand. Or when you feel like you've got at least the bare minimum. Because number 2, the bare minimum is the answer. But if you feel like you've got the bare minimum of the rest of them done, raise your hand. Check the last one in a minute. There's more you can do with it, but yeah, I don't know if it's better or not. You guys are my first Algebra 2 class today.
Algebra 2.
Or sorry, you guys are my first Algebra 1 class today, so I haven't done the warm-up yet. Sorry, I misspoke. I apologize. Watch on me. I didn't change the class on you guys without telling you. We mean the Algebra 2 class, I teach you love to be doing this right. The first one's right.
I have no idea how to
Okay,
I have no idea.
so the second one is y equals mx plus b. Okay, so it's y equals whatever the slope was times x. So the slope in this case is 1/2. You put an x down. And then plus whatever the y-intercept is, which is. Yep. That's it. That's all you have to do for the second one.
Okay.
The third one, you have to use an equation I gave you. And I'll write it down for you again here. So it's y minus y1 equal to m times x minus x1. So m is slope. And then you've got some point here that is x1, y1. So you just have to, like, the minimum I'm asking you to do is rewrite this with the numbers in. So instead of being y minus y1, it's going to be y minus the y point from that part, or the y point, the y part of that point. Right, so y minus negative 2 is equal to, then you're going to put down the slope, which is 4 over 5, and then in parentheses, x minus, and instead of x1, you're going to put the x part of the point. Yep. And we'll go over the rest of it in just a second, but that's enough for the bare minimum. Okay. Right.
Oh, okay. I thought that was your answer.
Anybody else? Nobody else?
Punch gum
No? Okay, cool. Brett, turn around. So, anybody have an idea about which saint it was or St. Patrick, yep. The one saint that is mostly associated with Ireland is the one who according to legends, drove the saints out of Ireland. It's not quite what happened, but that's what he's attributed for doing. Okay, guys. Second one, easiest type of problem you're going to get this entire unit. When we take a test or a quiz and you have this on it, there's no reason anybody in this class should get that second type of problem wrong. It's all you have to do is replace in y equals mx plus b, replace the m with whatever the slope is, which in this case is 1/2. And then replace y-intercept with whatever the y-intercept is, which in this case is 10. And that's it. Number 2 is done after you do that. Alright? Number 3, you're going to use that formula I gave you guys last week, which again, I keep saying this, but if it is not in your notes, you need to get it there. So y equals m times x minus x1. For your m, that first step is already done for you. You know that your slope, your m, is 4/5. Next, you're going to use your point that you're given, which is 10 and -2. By default, this is x1 and this is y1. You're then going to substitute your values into that equation. Y minus -2 equal to 4/5 times x minus 10. Now, before I go any further, I'm going to do some housekeeping and just change this minus -2 into plus positive. Next, the third step, you're going to distribute the 4/5 to both things inside. So if you did the bare minimum, which is writing the formula, next thing you're going to do is distribute 4/5 to both things inside those parentheses. Now, 4/5 times x is a lot easier than you think. Chris, what is 4/5 times x?
4/5 x.
Awesome. Just 4/5 x. Now, if you're doing 4/5 times 10, and you have a lot of trouble with fractions, here's the easiest way I can possibly think of to explain it to you. Right? You're going to do 4 times 10, which is what, Gunnar? And then divide by 5. Great. So this is going to be 8. 4/5 times 10 is 8. I'm going to drop down the negative, or the minuses. Over here we've got y plus 2. Final step, step number 4, is we're going to get y by itself. To get y by itself, are we going to add 2 or subtract 2, Brandon? Subtract 2. So we're going to minus 2, get a minus 2, and I'll get y is equal to what, Brandon?
4/5 x minus 10.
Minus 10. And there you go. Alright? Hopefully this is getting easier for you guys. Because we're going to start dealing with these in word problem situations later this week. So you gotta have this like down. Alright? Okay, go ahead and set your warm-ups aside. And then are there any questions on yesterday's assignment?
Can I get that?
You can, give me just a second.
14 and 16.
14 and 16, he says. Right. Gus is asking about question 14 and 16 from yesterday. Anybody else have any questions on yesterday's assignment? You handed it in yesterday. I'll find it for you in just a second. Right. So, wait, okay. Yeah. Sorry, I just want to go through these quickly here. People handed stuff in, which is awesome. That's first period, first period. Seventh period, eighth period. Sorry, give me just one second. Seventh period. Okay. So, 14 and 15. Could you tell me what number 14 is?
Through -4 and 4. And the slope is -1.
Sorry, say that again?
Slope is -1.
Okay. So to find the equation of line through this point, you're going to use those 4 steps I showed you guys, but the first step is already done for you. So first step is finding the slope, but you already know what the slope is. The slope is -1. The second step is putting it into that formula over there. So this has to be your x1, this has to be your y1. You're substituting it in, it's going to be y minus 4 equal to -1 times x minus -1. And plus positive. Distribute -1 to both things inside. So Gus, what is -1 times x?
-1.
Great. And what is -1 times plus 4?
4.
Right. So I'm going to write it as minus 4. Over here, this is y minus 4. How do you undo the minus 4, guys?
Plus 4.
Add 4 to both sides. Plus 4 plus 4. So y is equal to what? The -1x is definitely going to be there, right? And then -4 plus 4, what is that? 0. So you can add the plus 0 if you want to. You can add a minus 0 if you want to. Or you could leave it alone and just write it as y equals -1. That's perfectly fine. Was this 13 or 14?
That was 14.
Okay. So then we're looking at 15.
16.
16 is the other one you wanted?
Yeah.
Okay, could you tell me what 16 means, please?
Through 3/4. And the slope is 3/2.
Same thing. First step is already done for you. You already have the slope. So you know that the slope is equal to 3/2. Robbie, you're going to help me out with this one, alright? So, the next step is to set it up into that formula. So what should I write if I'm substituting stuff in the formula correctly?
Y minus 4
Great.
equals
3 over 2.
3 over 2,
Mm-hmm.
x plus
Should be minus 2.
3.
Mm-hmm. It only turns into plus 3 if it's a negative up here. Right? What's the next step?
Distribute.
So distribute 3/2 to both things inside.
So 3/2
Okay.
minus
What's 3 times 3?
9 and then
Okay. And what is half of 9?
0. Oh, sorry. Half of 9.
Mm-hmm. You have $9 you're splitting it between you and your friend. How much is this person pay?
4.
Yeah. So 4.5 if you want. It doesn't matter if you have this one be a decimal, it's just that the slope can't be a decimal. The slope needs to stay a fraction. So if you have this be 4.5, that's fine. It's just that slope is the only thing that can't be a decimal. Add 4 to both sides next. So if you owe somebody $4.50 and you pay them $4, do you still owe them any money? How much do you owe them? Okay. So minus 0.5 or minus 1/2, however you want to do it. There you go. Alright? Not so bad, yeah. Are there any other questions on yesterday's assignment? No? Nobody else has questions on yesterday's assignment? Weird. Okay. Alright, then, how about we... Sorry, I'm just taking a second. Okay, yeah. So then, how about we correct yesterday's assignment then? Did anybody hand theirs in yesterday?
I did.
my gosh. Okay. I know. Give me a second. They're here somewhere. Sorry, I am very disorganized this morning. Look, you guys don't have to yell. I just said I was sorry for being disorganized. Alright, well, I'm going to have to correct this one myself then. Go ahead and pass them forward and I'll grab them or put them in the box. Take out your notes for today. We'll do that.
Where's yours?
Grr.
No, you didn't. No, you didn't.
Grr. Alright. I'll have to organize it one day. Grr, grr, grr. Alright. Anybody else? Alright. So take out your notes, please. We'll get started with that. Yes. I don't know what this is. I can't read it from here. What is it?
Wrapping Y
Yep, that needs to be handed in today as well, if you haven't already handed it in. Alright, so today we're going to talk about parallel lines. Raise your hand, anybody who's ever heard the term parallel before. Okay. So, keep your hand raised if you've heard of the term parallel, and you can explain to me what parallel means. Alright, cool. Go and put your hands up. Lena, can you give me
parallel lines are basically lines right next to each other, but they do not, like, connect at all. So basically they're like an equal sign.
Okay, so they're lines that are... Do they have to be straight up and down?
No. They can be any which way.
Yeah,
be
they
like
could
this?
be any which way.
And they could be horizontal too?
As long as they're not like...
As long as they will never cross.
Or like... Yeah.
Okay. So parallel lines are exactly what Lena just said. One way that I like to think about it is you can use like the L's in parallel to kind of keep that in mind. Parallel lines are lines that will never cross. However, because you guys are in lines that will never cross, because you guys are in Algebra 1, I'm going to give you guys an extra definition to this. Lines that will never cross. I'm also going to say that parallel lines are lines with equal slope. Lines with equal slope. So as far as Algebra 1 terms go, yes, absolutely, lines that will never cross, that is parallel. It is also true that parallel lines are lines that will never cross one another. That is also what it means as far as Algebra 1 goes. So to do this, let's say that we have some line here that exists. We'll call it y is equal to 3x plus 5. Now if I asked you to graph that, you would go up 5, make your dot, and then count up 3, right 1, dot, up 3, right 1, dot, and then connect them. Yeah? That's how you do that kind of thing. Alright. If I'm asking you to find the equation of a line that is parallel to this, the only thing you know so far is that it's going to have the same slope. That's Mr. Schaff. She is. Oh wait. No, she's not. Sorry. Sorry. Yep, bye. Okay. So if I ask you to find the equation of a line that's parallel to this one, you know for one thing for sure, and that is that the slope is going to be exactly the same. So it's going to be parallel to anything that has 3 in front of the x. It could be 3x plus 10. It could be 3x minus 100. It could be 3x plus 57,000. Like, all of these lines are going to be parallel to that other line over there. So they have the slope that is the same, but the y-intercept is going to be different. Now how this works as far as your assignment today goes is I'm going to be giving you an equation of a line. Let's say it's y equals 3x plus 5. 3x plus 5. And I want to know the equation of a line that is parallel to it and also goes through a specific point. And to find out what that point is, Brett, can you give me a number, please?
7.
Okay. And then, Sage, can you give me another number, please?
3.
Okay. So I want to find the equation of a line that is parallel to this, meaning it has the same slope, but goes through this point. So this is very, very similar to what we were doing as far as your warm-up goes. You already know what the slope has to be, right? Because it has to have a slope of 3. You know that your slope is equal to 3. So you're going to say slope is equal to 3. And then the rest of the steps are the same as what we have been doing. Bless you. Step number 2, you're going to use the equation I gave you guys, and this is another occurrence of it in your notes. Y equal y1, or sorry, y minus y1 is equal to m times x minus x1. You're going to substitute this in for x1, 7. You're going to substitute this in for y1, 3, and then this is your m. So this is going to be y minus 3 equal to 3 times x minus 7. I feel like I'm going really fast through this. You guys okay with it so far? Alright. If you're not, you're certainly not saying anything, so that's something. Alright, now from here, I mean, it's just 2 more steps. Step number 3 was to distribute the 3 to both things inside. So 3 times x, 3 times 7. So 3x minus 21. This is still y minus 3. And step number 4 is to get y by itself. So how would we do that, Chris? How would we get y by itself in this case?
Add 3 to both sides.
Great, so plus 3 plus 3. So y is equal to 3x.
3x minus 18.
Awesome, nice job. And that's it. I mean, that's all I'm adding today, is just that making sure that you understand that a line is going to be parallel to another line if they have equal slopes. Tomorrow we'll talk about perpendicular, but I just want to add them one at a time. Usually, in the past, I've been adding them both at the same time, and it seems to have caused a lot of confusion. But that's all I'm adding for today, it's just parallel lines. So your assignments. I'm going to require you to do some graphing because you are not provided with a graph. So the graph paper that I'd like you to use is in the back of the room. Underneath it's on the shelf that's underneath where the hand is back.
See, picture your girlfriend one. Oh, like that's good.
You can work with somebody else if you want to, but you know, actually be working with these. It's not that big of a deal. I don't think she appreciates it.
So we have to do graph one from like 11 through 14 and then that's it?
Do you want to have to graph more? Okay.
I
It's
grabbed
fine
the
if you do.
graph. No. I was just, I thought there'd be more.
Only 4 problems. That's all you need to graph.
You can save that graph paper for next time then, if you have more than one piece. So, like I said, if you want to work with somebody else, you can, that's fine.